bromocyclohexane, Aditi. But whatever I think so, somewhat you got as a structure.
No,
Is it
so
right?
like if we shift the hydrogen to the other carbon, to the second carbon, we can make it.
No,
We can
at least I'll give the numbering. I'll give the clarity here. 1, 2, 3, 4, 5, 6. Now just to make it sure that at which position we can take the substitution. That's it. So now I had given the numbering now. So which position? The first position, second position, third position, fourth position, fifth position, sixth position. So where we can add substitution? Where we can add, man? Aditi. Actually, allylic position, man. So NBS.
third or sixth one.
Very good, man. Third or sixth one, the third position. So third position means you look at as like this here. According to that one, how we can give the numbering 1, 2, 3, 4. Sorry, this is the 3. This one is 4. This one is 5. This one is 6. Okay. Either
So
maybe
they haven't given an extra methyl group or any carbon chain to the cyclic compound, then we should directly go for allylic carbon.
Yes, ma'am. Allylic carbon only. Okay, so because of that is only the condition, na? NBS, N-bromosuccinamide is going to be substituted. Okay, so according by treating with the NBS, N-bromosuccinamide, bromine is going to be substituted at either allyl carbon position or benzyl carbon position. That is only the condition. Okay, either it is attaches to the benzylic carbon or either it is attaches to the allylic carbon. Now I have given as a cyclohexene. In cyclohexane, which one is the allylic position? Means third and sixth positions are the allylic position. That one hydrogen atom is replaced by the bromine. Okay, so hydrogen atom is replaced by the bromine. Then only comes as here 3-bromocyclohexene. What is the name of the product? Means here 3-bromocyclohexene. Okay, now one more structure like this only. Kathy?
Yes, sir.
So what is the product? I'll give the numbering 1, 2, 3, 4, 5, 6. At which carbon atom we can take the substitution?
Sir, it will be the third one.
Yeah.
Kathy, what's your answer?
Yeah, sir. I also was going to say that.
So it is also third one only. Okay.
Yes.
Now
sir.
the substitution will take place at here third position. So because of third carbon is the act as allylic, with respect to this side also it becomes as allylic. With respect to this one also it becomes as allylic. Hence bromine is going to be substituted at third position. Got the clarity?
Go to the sixth position.
No problem. But only one. Either you have to take as a third or sixth position. Only one position only takes the substitution, but it won't take as a two positions.
So will there be a minor and major?
No, in this one no major and no minor.
Okay, sir.
Because of Kathy, very good question. You asked you, sir, why can't take as a sixth position? That is, it is the structure. Okay, it is the structure. Now you are telling that why can't the sixth position means bromine here. Now how we can give the numbering 1, 2, 3, 4.
Sir, anyways, it will be the same compound, right? Because we only change the number in.
Number it is, that's it. Same carbon only. So here also we can give the numbering 1, 2, 3, 4, 5, 6 only. What's the difference it is there? Is there any difference it is there with both?
No, sir. Got it.
So that's why if you take the third or sixth position also, you will get as the same product of B. Got it? Okay, so that is the answer. So now you got the clarity. Then we'll go for the another methods here. So what are the another methods we are having here? That from alcohols also we can prepare as a haloalkanes. Okay, from alcohols. From alcohol, so many reactions are there. Okay, from alcohols also we can prepare as a haloalkane. So how we can prepare means here, when the alcohols are treated with hydrogen iodide in presence of red phosphorus. Okay, hydrogen iodide in presence of red phosphorus. It's not the red phosphorus here, so we can't decide it act as a reducing agent. It converts into the so it is treated with the hydrogen halides here, halo acids. If it is treated with here, halo acids. What are the halo acids we can take? Either hydrogen chloride, hydrogen bromide, hydrogen iodide also. So what is the reactivity of the halo acids? When the alcohols are treated with halo acids. Halo acids. Okay. What is the reactivity of the halo acids? Reactivity of halo acids is HI is greater than HBr. HBr is greater than HCl. Now in this one, if the alcohol is treated with the hydrogen iodide, it forms R bond I plus H2O is going to be. For example, if it is treated with the HCl, it is forms as a R bond. Okay, Cl plus H2O is the product here. Okay, and what is another one means here? So we have a one test. Lucas reagent. Lucas reagent. Have you listened to the name of the Lucas reagent, ma? So what is meant by the Lucas reagent means? Lucas reagent is nothing but it is the mixture of anhydrous ZnCl2 and anhydrous ZnCl2 and concentrated HCl mixture is called as a Lucas reagent. Okay, it is used identification of primary, secondary and tertiary alcohols. It is used in the identification of the primary, secondary and tertiary alcohols. Okay, tertiary alcohols. Now, same reaction. Again, where we are going to study means here, in alcohols chapter, you will get same reaction here. Confirmation test of the alcohols, actually this one. So we can call as a confirmation test of the alcohols. Okay, so and practical also. So now you are going to do some of the practicals now. It is Viva question. What is the confirmation test of the alcohols means Lucas test. Sir, what is the Lucas test means here? Sir, actually alcohols are colorless liquids. We are taking as a 3 test tubes. We are taking as a 3 different alcohols in a 3 test tubes. For that one, if you add Lucas reagent, means, let us see, first primary alcohol it is there. So what is the example of the primary alcohol means? I'm taking as a ethanol, my CH3 bond, CH2 bond, OH. Second one I'm taking as a secondary alcohol. CH3 bond, CH bond, OH bond, CH3. So first I'll take reverse manner here. Tertiary, secondary, primary alkyl acid. Tertiary, secondary, primary alkyl acid. To make you understand. CH3 bond, C bond CH3, bond OH, bond CH3. So this one is the secondary. CH3 bond, CH2 bond, OH. Okay. So first one is the primary alcohol, secondary alcohol, or tertiary alcohol. First one. First structure. Any one of you. Kathy, Aditi.
Sir, is it tertiary?
It's the tertiary. It is the tertiary alcohol. Second structure.
Secondary, sir.
Second structure is secondary. And first structure, ma?
No, it's primary, sir.
First one is primary because of OH group is attaches to the primary carbon. This one is the secondary carbon. This one is the tertiary carbon. Now, if the tertiary alcohols are treated with glucose reagent, okay, treated with the glucose reagent. So glucose reagent is example of the nucleophilic substitution reaction. In that one, OH group is replaced by the Cl. If the OH group is replaced by the Cl. If the OH group is replaced by the Cl means it forms CH3 bond, CH3 bond, bond CH3, bond Cl. Okay, so what is the product it forms means here? It converts into the tertiary butyl chloride. Okay, so it converts into the tertiary butyl chloride. So when the tertiary alcohol is treated with the glucose reagent, it gives immediate turbidity, immediate turbidity. So immediately it is going to form as some precipitate. Actually, glucose reagent also it is the liquid, and tertiary alcohol also it is liquid. So when you add one liquid into another liquid, immediately you got as some solid substance. It forms as some solid substance here. So that is only we can call as a turbidity. The turbidity is contains here tertiary butyl chloride. Okay. Now alcohols are converted into haloalkanes only now. Okay, and similarly secondary alcohol. So when the secondary alcohol also it is treated with the glucose reagent, it forms 2-chloropropane, CH3 bond, CH bond, Cl bond, CH3. In the formation of the 2-chloropropane, it takes 5 minutes time. It takes 5 minutes, my dear. Okay, turbidity is formed within 5 minutes. Turbidity is formed within 5 minutes. Turbidity is formed within 5 minutes. Now you got the clarity. And similarly, the primary alcohols, room temperature, at room temperature does not react. By changing the high temperature, it reacts with the glucose reagent. Okay, so based on these three tests, we can identify now. So which one we give, whether the given alcohol is primary alcohol or secondary alcohol or tertiary alcohol. Okay, so this test also you are going to do in the laboratory. Practicals are there. Actually, practicals means volumetric analysis, salt analysis, identification of the organic compound is there. Okay, there also you are doing confirmation test of this one. Now got the clarity, ma? When the alcohols are treated with the glucose reagent, if it is treated with the tertiary alcohol, it reacts with the glucose reagent means it forms as a tertiary alkyl halide. If the secondary alcohols are treated with the second glucose reagent means it forms as a secondary alkyl halide. Okay, and primary alcohols are treated with the glucose reagent. Primary alcohol that does not react with the room temperature. By changing the reaction conditions at high temperature, they react and they form as a primary alkyl halide. Now we got the clarity. Okay.
Yes,
And
ma'am.
some other reactions also it is there from the alcohols only, but reagents are different. So what are the other reactions are that means when the alcohols are treated with phosphorus halides, okay, second one here, phosphorus halide, C2H5OH is there. C2H5OH is called as ethanol. C2H5OH is called as here ethanol. Okay, ethanol. Ethanol means, let us see here, PCl3 is there, PBr3 is there, okay, PI3 also it is there, PI3 also it is there. If the ethanol is treated with the PCl3 means it forms, when ethanol is treated with the PCl3 means it forms ethyl chloride C2H5Cl plus 3 moles of 3 moles of the C2H5Cl plus H3PO3 is going to be formed. What is the byproduct you are getting means here? H3PO3 is going to be formed. So this is the byproduct here. Similarly, when the ethanol, sir, how you got as a 3 moles of the ethyl chloride means at PCl3, how many chlorine atoms are there? In PCl3, how many chlorine atoms are there, ma? Aditi? In PCl3, PBr3, Pi3,
3.
3 are there. So that means one chlorine atom, it replaces the one alcoholic group. So like that, how many alcohol groups are required to us? 3 alcoholic groups. So that's why I had taken as a 3 moles of the ethanol. If the 3 moles of the ethanol is reacts with 1 mole of the PCl3, it forms 3 moles of the ethyl chloride plus H3PO3. And similarly, if it is reacts with the PBr3, it forms 3 moles of the C2H5Br plus H3PO3 is the product. Similarly, Pi3 also. Okay. And one more condition. So what is another condition mean? C2H5OH is reacts with PCl5. PCl5. Okay. If this reacts with the PCl5 means what are the products it forms means? It forms ethyl chloride, C2H5Cl plus POCl3 plus HCl is the byproduct. HCl is the byproduct. Based on this one also sometimes they're asking the question. Because of PCl3, PBr3, Pi3 means you'll get as a phosphoric acid is the product here. Okay, but in this one, whenever it is treated with the PCl5, you will get as a different products. Okay, they are not asking the alkyl halide, so they are asking the sub products. What are the byproducts it is found when the alcohols are reacts with the PCl5? Got the clarity? Okay. Next, one more important reaction. Named reactions are here. What are the named reactions we are having means here? D'Argens reaction. D'Argens reaction. Okay. Now we are going to write the board examination. In board examination also they'll ask the questions based on the named reactions. D'Argens reaction. Sir, what is meant by the D'Argens reaction means? D'Argens reaction is one of the best method. One of the best method to synthesize okay, haloalkanes. Synthesize one of the best method to synthesize haloalkanes. Sir, why we are calling as a one of the best method means here, for example, in this one, if alcohols C2H5OH is treated with thionyl chloride. Sir, what is the molecular formula of the thionyl chloride means SOCl2. Okay, so this we can call as here thionyl chloride. Thionyl chloride. If it is treated with the thionyl chloride, it forms ethyl chloride C2H5Cl plus SO2 plus HCl. In this one, HCl also gas, sulfur dioxide also gas. Sulfur dioxide and HCl both are expelled into the atmospheric air. Sulfur dioxide and HCl both are expelled into the atmospheric air. Then you will get as a pure alkyl halides only now. Will get as a pure alkyl halides or not? So sometimes they're asking the question mark. Okay, so which of the following is one of the best method to synthesize the alkyl halides? Okay, so which of the following method is one of the best method to synthesize the alkyl halides means the D'Argens reaction is one of the best method to synthesize the alkyl halides. Now we got the clarity. Okay, so why the D'Argens method is one of the best method to synthesize the alkyl halides? That is my question. Why it is one of the best method, ma? What is the reason? What is the reason, ma? Any one of you? Aditi? Ma, hardly 4 reactions are there, then I'll stop. Hope so you also got bored. Okay, so only 3
Because
reactions.
SO2 and HCl are gas and they can release in the atmosphere.
Yeah,
quickly.
sir, and only
Ah.
C2H5Cl
Yeah.
is left.
Okay, so here byproducts, whatever we are getting means SO2 and HCl are the byproduct. Both are the gases only. These both are expelled into the atmospheric air. Both are expelled into the atmospheric air. Then we'll get as a pure product is alkyl halide only. So that's why D'Argens reaction is one of the best method to synthesize the haloalkane. Okay, and what is another method here? So Hunts-Becker, borodine Hunts-Becker reaction again. Okay, so what is another reaction means here? Borodine Hunts-Becker. Okay, Borodine Hans Decker. ECK Borodine Hans Decker reaction. So by using the Borodine Hans Decker reaction, we can prepare as a bromoalkanes. This method is used to prepare bromoalkanes. Sir, how we are going to prepare the bromoalkanes means? So we are taking as a silver carboxylate, CH3 bond, COO, Ag we are taking. So silver carboxylate carboxylate is reflux with bromine in presence of carbon tetrachloride. Okay, so reflux here we are heating. Okay, so we are heating for a long time. We are heating around 1 hour, more than 1 hour we are heating here. So whenever the silver carboxylates are treated with bromine in presence of carbon tetrachloride and reflux means we are heating at a long time. So whenever it is heated means it forms alkyl bromide, that means methyl bromide CH3 bond Br plus AgBr plus carbon dioxide gas is going to be released. It releases the carbon dioxide gas. And in this one, if you compare with the reactant and product is having one carbon atom less than that of the reactant. Either it is correct or not here. In Borodine Hansa-Decker reaction, whatever the products it is forming, that it has one carbon atom less than that of the reactant. Either it is less or not. So if you see the first one, okay, so this we can call as a silver ethanoate. How many are there? 1, 2 are there. So this we can call as a silver ethanoate. Eth means 2 carbon atoms are there. But in methyl bromide, so what is the product you got as here? You got as a methyl bromide. You got as a product is methyl bromide. How many carbon atoms difference is there with the comparing with the reactant product? How many carbon atoms difference it is there?
1.
Ritu, to compare the react. So how many carbon atoms, ma'am? 1 carbon atom difference it is there. So 1 carbon atom it is more or less. 1 carbon atom it is more or less for in the products.
Sir, it is less.
It is less, ma'am. So products are having 1 carbon atom less. Okay. Next, Finkelstein reaction. Finkelstein reaction. So Finkelstein reaction is used in the preparation of iodides. It is used in the preparation of iodides. Okay, how we are preparing means here. So alkyl chlorides and bromides, RCl, RBr, alkyl chlorides and alkyl bromides are treated with sodium iodide in presence of dry acetone. If it is alkyl chlorides and alkyl bromides are treated with the sodium iodide in presence of dry acetone, they form alkyl iodides. So byproducts are we can get as here NaCl and NaBr. Okay, you may get the doubt, sir. Why we can't prepare halides, that means chlorides and bromides by this method means here. So whenever you take as a sodium chloride in dry acetone, it gives as a solid substance. It is not forming as a product. Okay, so because of by adding the NaCl, the temperature is going to be decreases and it forms as a solid substance. That's why this method is useful to prepare only iodide. Okay, by using this method, we cannot prepare chlorides and bromides. Okay, so by using the Finkelstein reaction mechanism, we can prepare only iodides. We cannot prepare as a chlorides and bromide. Because of chlorides and bromides they form as a salt with the dry acetone. Okay, sodium chloride and sodium bromides they form as a salt with the dry acetone. Solid substance they form as here. Got the clarity? Okay. Last reaction. Schwartz reaction. Schwartz reaction. Okay. Schwartz reaction. So Schwartz reaction is used to prepare. It is used to prepare. It is used to prepare fluorides. It is used to prepare here fluorides. So how we are going to prepare means here when the alkyl chlorides and alkyl bromides are treated with higher metal fluorides. Treated with here higher metal fluorides. Higher metal fluorides. So what are the higher metal fluorides? This means here COF2, which is there. Okay. So cobalt fluoride, cobalt trifluoride, CuF3. CuF3. CuF3 or AgF, silver fluoride or arsenic fluoride, AsF3, antimony fluoride, SbF3, mercurous fluoride, Hg2Fe2. If you take any reagent, if it is treated with the any reagent, means it is converted into the alkyl fluoride. Okay.
Sir, does
Yes, ma'am,
COF2
Ritu.
also come under? Sir, does COF2 also come under higher metal fluoride?
Cobalt trifluoride, that one. It's not the carbon monoxide. CO is nothing but cobalt trifluoride. Cobalt trifluoride. Cobalt trifluoride is it is act as a higher metal fluoride. Okay.
Okay, sir.
Okay, ma. All of you got the clarity. All these are the different types of the preparations we are using in the preparation of the alkyl halides. Okay. Tomorrow aryl halides preparations is very less. It is that immediately we are going to finish. Then we are going to discuss about the chemical properties of the haloalkanes. Okay. So tomorrow also can I take 10 to 12? Is it okay for you?
Yes, sir.
Yeah.
Tomorrow and
Yes.
after tomorrow I will finish this chapter. Okay. Then so tomorrow at the same time. So we'll continue in the tomorrow class. But coming tomorrow, just go through this one and you can solve the questions from your assignment. That means you are having material now. You can solve the questions from that one here. Okay?
Yes. Sir, could you add this as a resource in the group?
Definitely, ma'am. Now only I'll forward here. Okay. If you
Okay,
want
sir.
notes,
Thank you.
I will add the notes here. Then fine. So we'll continue in the next class. Thank you.
Thank you,
all.
sir.
Thank you, sir.
Yes, sir.